Deforestation refers to the large-scale removal or clearing of forests, primarily driven by human activities such as logging, agriculture, mining, and urban expansion. Deforestation has significant implications for climate change due to its impact on the environment, carbon cycle, and ecosystem functions. Here's how deforestation is linked to climate change. Carbon dioxide emissions. Trees and forests act as carbon sinks, absorbing carbon dioxide, CO2, from the atmosphere through photosynthesis and storing it as biomass. When trees are cut down or burned during deforestation, the stored carbon is released back into the atmosphere as CO2. This contributes to the greenhouse effect, leading to higher concentrations of greenhouse gases and global warming. Loss of carbon sequestration. Deforestation reduces the Earth's capacity to capture and store carbon dioxide. Healthy forests are effective at sequestering carbon, helping to mitigate the effects of climate change. Removing trees diminishes this natural carbon sequestration process. Altered weather patterns. Forests play a role in regulating local and regional climates through processes such as transpiration, which releases water vapor into the atmosphere. This affects cloud formation and rainfall patterns. Deforestation can disrupt these processes, leading to altered weather patterns and potential shifts in precipitation. Loss of biodiversity. Forests are home to a wide variety of plant and animal species. Deforestation leads to habitat destruction and fragmentation, increasing the risk of species extinction. Biodiversity loss can disrupt ecosystems and reduce their resilience to environmental changes. Feedback loops. Deforestation can create feedback loops that exacerbate climate change. For example, as temperatures rise due to increased greenhouse gas emissions, some forests may become more susceptible to wildfires, which release more carbon into the atmosphere. Deforestation and land use change. Deforested areas often undergo changes in land use, such as conversion to agriculture or pastureland. These changes can result in increased emissions from activities like livestock production and the use of fossil fuels for agricultural machinery. Positive feedback effects. The loss of reflective forest cover can contribute to the albedo effect, where darker surfaces, such as cleared land, absorb more sunlight, leading to further warming. Efforts to address deforestation and its link to climate change include: reversing deforestation efficiently requires a combination of strategies that address the underlying drivers of deforestation, promote sustainable land use practices, and restore degraded ecosystems. Here are several key approaches to efficiently reverse deforestation. Afforestation and reforestation. Planting trees in deforested or degraded areas is a direct way to restore forests and sequester carbon. Native tree species should be chosen to restore ecosystem diversity and function. Agroforestry. Integrate trees into agricultural landscapes to achieve both food production and reforestation goals. Agroforestry systems can provide economic benefits while restoring ecosystem services. Sustainable land use practices. Promote sustainable logging, farming, and grazing practices that minimize environmental impacts. These practices can include reduced impact logging, rotational agriculture, and managed grazing. Restoration of riparian zones. Protect and restore areas along rivers and streams, as these zones are critical for biodiversity and water quality. Healthy riparian zones can help prevent erosion, filter pollutants, and regulate water flow. Community-based conservation. Involve local communities in restoration efforts. When communities have ownership and benefit from forest resources, they are more likely to participate in conservation and restoration activities. Protected areas and reserves. Establish and effectively manage protected areas and wildlife reserves to conserve critical habitats and ecosystems. Policy and legal frameworks. Enact and enforce laws that prohibit illegal logging and land conversion. Provide incentives for sustainable land management and restoration activities. Financial incentives. Offer financial incentives to landowners and communities for participating in reforestation and restoration projects. Payment for ecosystem services (PES) programs can reward land stewards for carbon sequestration, water provision, and biodiversity conservation. Technology and monitoring. Use technologies such as satellite imagery, remote sensing, and geographic information systems, GIS, to monitor deforestation and restoration progress. This helps track changes and guide decision-making. International cooperation. Collaborate across borders to address transboundary issues, such as illegal logging and trade in timber products. Public awareness and education. Raise awareness about the importance of forests, biodiversity, and ecosystem services. Educate the public about the benefits of reforestation and restoration efforts. Research and innovation. Invest in research to develop new techniques and approaches for reforestation and ecosystem restoration. This includes studying the best tree species for specific ecosystems, improving planting and maintenance methods, and understanding the social and ecological dynamics involved. It's important to note that successful reforestation and restoration efforts require a holistic approach that considers ecological, social, and economic factors. Collaboration among governments, communities, NGOs, and the private sector is crucial for achieving meaningful and efficient results in reversing deforestation and restoring ecosystems.